This conference will now be recorded.
In this section, we are going to discuss about ASM deployment types, and then a bit about setting up HA. When you are setting up HA, what are the various parameters that we need to take care of, and bit about supporting the ASM device. So let's get started with ASM deployment types. The first deployment type would be ASM as a standalone appliance. When I say standalone appliance, it means that here we are purely concentrating on protecting our apps against attacks. There is no load balancing feature which is coming into picture. There might be certain scenarios wherein the developers directly want to manage their application security. They don't want a load balancing feature along with ASM. So in those scenarios, we have LTM implemented separately and ASM implemented separately. So when you have a single appliance only with ASM module, we call that as ASM standalone deployment. Then you might have multiple ASM devices behind a big IP LTM. So this would be something like, let's say this client, the incoming traffic is coming to your F5, which is your LTM. This is the virtual server, which will be mapping to a specific pool. And in this pool, you will have then different set of ASM appliance. Let's say this is ASM1, ASM2, ASM3, ASM4. So on each you would be having one virtual server, and then behind this you will have the servers. So F5 is load balancing across all the various ASM devices. So generically, if you consider, the performance of ASM module is sufficient for most of the environments. However, again, in some organizations, the performance requirements might not be met with a single appliance. So in those scenarios, deploying multiple dedicated ASM devices behind a LTM delivers a higher performance level. And deploying dedicated ASM devices can allow the organization to even scale on demand. Like when any new ASM is required, it can easily be added just to the LTM pool. So by using LTM in front of these ASM devices, the ASM basically operates in fail open mode. If at least one of the ASM device is available, the big IP LTM traffic will be able to send the traffic to the backend servers. And it is very unlikely that all of the ASM devices go down at a single point of time. Then the next deployment type would be ASM inline with big IP. So in certain environments, there is a need to send the web application traffic through LTM and then have the traffic secured by a AS standalone appliance. So your traffic first comes to LTM, and then from LTM it goes to the ASM. Then from ASM it goes to the server. So with this specific architecture, the load balancing features, whatever we want to make use of LTM features, we can do it here, and then security we can configure here with respect to our application. Then the next type of deployment is ASM module on LTM. So let's say at initially you purchased a new appliance which has with only LTM feature. Now you want to scale up, you want to add up more security to your application. So you just purchase ASM license and add it on the same box. So in this manner, basically organizations can make use of existing features on ASM as well as add up the security features related to ASM on a single appliance. Then another deployment method is span configuration. Span is nothing but switched port analyzer. Or this is sometimes also called as port mirroring or passive mode. So in this mode, what happens is all the network traffic, the switch mirrors basically and sends it to the span port where the ASM is connected. So let's say this is your client machine. Client sends the traffic to switch 1, from where let's say it goes out to router, and then from here it goes out to your server. So whatever incoming and incoming from here, or maybe outgoing traffic, incoming or outgoing traffic coming into the switch just mirrors everything to maybe this port. This is your with port mirroring enabled. So what switch does is it just copies all the data and sends it to your ASM appliance. So ASM basically reviews all the information which is passing through, and it does not modify it. So this kind of deployment is only used when you want to log each events, or maybe you want to use ASM for displaying reports. You don't need to configure anything extra in your network. You're just trying to a use case of this deployment would be if you are just trying to evaluate the product without any performance impact. You want to see how ASM works, how it is processing the traffic, what is it that it is logging. So in this specific deployment, we use the template called as passive deployment template in policy building. So now these were the different deployment methods in which you can integrate or install ASM in your network. Now, when there is a need for redundant system configuration, it is essential that each ASM system, ASM1 or ASM2, synchronizes its current configuration data with the peer. And if for some reason, let's say the synchronization is not working, again, there is no point of having a HA, because when it fails over, it will not be able to handle the same traffic in the same way that ASM1 was handling, which when it was active. So on an ongoing basis, a config sync is executed between both the appliances. So whenever a config sync process is executed, basically a MySQL dump is placed or is performed, placing all your security policies and the web application data in the .ucs file. And this file is again located in var local directory. And ASM security policies or the security policy history as are also synchronized using this MySQL database. There are only certain parameters like traffic learning, or you can say the event requests. These are not synchronized between the peers. So whenever we talk about setting up a HA, there comes a term called as device group. Device group is nothing but two or more big IP devices which use the same configuration and provide consistent security policy enforcement. This specific device group implementation comprises of two phases. First, that you establish a device trust between the two appliances, appliance A, appliance B, and this is usually achieved by exchanging the certificates. And then the next step or next phase is adding the ASM device that are members of this device trust to a device group. And then we enable ASM synchronization. With respect to that device group. So whenever you set up ASM synchronization, basically security policies or other settings like custom attack signatures, when you enable ASM synchronization, you would have the security policies synced, custom attack signatures, any logging profiles that you would have created, SMTP configuration, or maybe any other system variables that you would have configured, any specific policy templates that you would have used. These are synchronized between all the devices in a device group, which is ASM enabled. Now, when we are using the device management within ASM, we need to keep in mind few things. First, that big IP system with ASM. With ASM can be a member of only one ASM enabled device group. You cannot have the system to be a part of multiple device groups. Then the big IP system in a device group must be on same version, including any hotfix that you have installed. Then the real-time policy builder can run on only one system. You cannot have the policy builder running on both your appliances. So, for example, you can set up the automatic policy builder on one system, and then when the policy is being built, this policy just is built on that system and automatically updated on all the systems in the device group. Then, if let's say you are using Viprion platform, which comes with, let's say, multiple blades, then we need to understand that it is considered as one device and you need to add only the master blade to device trust and group. So now the question arises is, how do you enable ASM synchronization on the group? So in order to do that, you have to move to application security, and from here you need to click on synchronization. This is wherein you select the device group among which you want the synchronization to be enabled. So now that we have discussed about HA and synchronization, in order for ASM or administrator to start troubleshooting any issue that comes in, like in LTM we have QK view, in ASM we have something called as ASM QK view. This script automatically collects any configuration or diagnostic information from your ASM appliance. And this is one main important information which you would be requiring when you are trying to log a case with the vendor as well. So the ASM related configuration files or log files which will be actually collected by this ASM QKView script would be like anything in var log ASM, anything related to var lib MySQL, any database errors, or anything in TS log, or this config file under which is under TS directory. So it creates a, and then MySQL dumps as well. of the databases. Now the question is, if you want to run a ASM-QK view, how do you run it? So it is quite simple. There is no option to run ASM-QK view from GUI as you have an LTM. So you need to have access to the command line, and in command line you just type this ASM-QK view and give enter. So it would generate a QK view file in var temp folder. Now again, with respect to this ASM-QK view, you have some command options as well. Maybe to specify a maximum size limit of this ASM snapshot which gets created, you can use something like this: ASM QK view minus minus size underscore limit equal to maximum size in bytes. So this way you can limit the ASM snapshot file which gets created. And specifically for troubleshooting, it is also required that when you are creating this ASM-QQ file, you include the request logs as well, the event logs. So in order to do that, you would use the command as ASM-QKView minus add minus proxy minus log. So with this, we complete this section. We'll continue a new topic in the next section.